So hi everyone, today is 9th of January 2023 and we are going to do the daily question of LeetCode. Today's question is binary tree preorder traversal. Now the prerequisite is you have to know the binary tree before going ahead, and to travel a binary tree we have three ways: in order traversal, pre-order traversal and post-order traversal. In this question we are given a root of the binary tree and we have to return the pre-order traversal of its nodes value. Now, let me explain you what is pre-order traversal first of all. For example, look at this diagram which is given of the binary tree. We have 1, null, 2 and 3. So in pre-order traversal, what we have to do, we have to follow a principle in which we have to do operation first, then we have to travel the left of the tree, and then we have to travel to the right of the tree. This is the whole principle of it. Now, to make it more clear, let's just take this example and just travel this tree. Okay, so we are going to see two methods of it. One is the recursive way and the second one is the iterative way. There is other way also, which is the Morris traversal. Now I'm not going to explain you in this video what is Morris traversal. Okay, so what is like how will travel this? What is a pre-order traversal? First of all, in pre-order traversal we have root. Okay, so do the operation on the root first of all, and then what you have to do, travel to the left, and then what you have to do, travel to the right. So this pattern we have to follow in pre-order traversal. Okay, so in pre-order we have to follow this. Now let me just do it like recursively make the tree of it and just draw it. So what I'll do is, first of all, I'll make a vector. Why to make a vector? Because I have to store it, or basically the answer which I have to return back is in the form of vector. So I have to make a vector and I'll push that vector inside it. Okay, so what I'll do is, first of all, I'm at the root, I'm at this place at 1. Okay, so first thing, basically pushing the thing to the root. Okay, so I'll push the thing to the vector. So 1 is here. Okay, what I'll do next, I'll travel to the 2. So I'll make a tree so that it is more clear. 1 after this 1, what I'll do, I'll travel to 2, the left of it. Okay, the left of it. So I'll go to 2. Again I'll check that there should be the left of it. I'll travel the left of it again. Okay, because I have to travel to its left again. So I'll go to the root. Basically the root is this. Okay, and before going to this left, what I have to do, I have to print it, or I have to just push it to the my vector answer. So what I'll do is, I'll just push it to my vector, and then after pushing it to the vector, then I'll move to the left. Okay, so after traveling to the left, I'll find 5. So here is 5. Okay, so as soon as I encountered again the root, what I'll do, simply just push it to the vector. So here we have to push it again to a vector 5. Now after going traveling to this 5, again what I have to do, I have to travel to its left, and after traveling to its left, what I'll find null. And in case of null, what I'll do is, I'll just basically return from it. Okay, I'll do nothing and I'll just return from it, because the function will return itself. Okay, so I'll return from it and I'll come back to this 5. Okay, I'll come back to this 5. Now after traveling, after seeing that I have traveled the left of 5, what I'll do, I'll travel to its right. Okay, let's just travel to its right. And after traveling to its right, what I'll see that yeah, we do not have null, we do not have any element on the right itself. So what I'll do, I'll again go back. Okay, recursively I'll go back. So after going back, what I'll do is, I'll see that I have traveled both left and right of this 5. I'll go back. Okay, so again this will go back. Now after going back from here, what I'll see that this 2, all the left of it has been traveled. Now I have to go to its right. Okay, let's just go to its right. After going to its right, what I'll see, that we have 6. So we have encountered 6. As soon as I have encountered 6, what I have to do, I have to push it into this vector. Okay, let's just push it to this vector. So we got 6 here, so 6. Okay, so I have to erase it from here because, okay, it's not erasing, no problem. So we'll draw a line here. Okay, now again what I have to do, I have to travel again the left and right of 6. So when I'll travel to left of it, I'll find null. Okay, so Rishabh, what you have to do then just don't do anything, just come back. Okay, come back to this 6 again, as in this case. So I'll come back. Okay, I'll come back again. What you have to do is you have to travel to its right. Okay, just travel to its right. We'll find nothing. What we'll do, we'll come back. Okay, just come back. After seeing that I have traveled both left and right from the 6, what I'll do, I'll come back again to 2, है ना? This is the simple thing that I just wanted to tell you. After seeing both these arrows, okay, what 2 will say, okay, I have traveled my left and right, what I have to do, I have to go back. Okay, this 2 will also go back. After seeing that I have traveled my whole left, what I have to do, I have to go to my right. Okay, just go to your right. And after going to right, what this will encounter 3. As soon as I encounter 3, what I have to do, simply just put it into this vector. So I'll put this into this vector. Okay, this is, so 3 is inside my vector. Now again what I'll do, I'll just go to the left, nothing encountered, come back. Go to the right, nothing encountered, come back. After traveling left and right, go back. After traveling left and right, just come out of the program and just return this. Okay, so what I'll do, I'll just return it, return this vector, return vector. So this is the approach, we can say one of the approach which is recursive approach. The other approach that I'll tell you is the iterative approach. And before moving to the iterative approach, let me just take you to the code of it, the code of the approach that we have discussed. So it's a recursive approach. First of all, I have declared a vector, and inside that vector, the answer is vector. Okay, this is the name. And after inside the function, what I am doing is, if there is root, okay, and the root should not be null, then what you have to do, you have to first of all push back. So do the operation and just push back the root value to the vector, and then what you have to do is to pre-order traversal. This is syntax. Okay, so we have to call the function again and again in recursion. What I am doing is I am calling a function and root left. Okay, and again what I am doing, pre-order traversal, root right. So this is the root, this is left, and this is right. Okay, so this is the pre-order traversal. Now one more method is there. The method is iterative. When inside the iterative method, what you have to do is you have to maintain a stack, and inside that stack, what you have to follow some simple rules. Okay, what are the rules, Rishabh? Okay, so when you encountered anything, when you encountered the root, just push it. Okay, just push it to the vector. So I'll again make a vector inside this. So vector. Now as soon as I encountered 1, what I'll do is I'll encountered 1, and I'll push it to this stack. Okay, push it to this stack. Oh sorry, not the stack, this vector. Okay, and after that, after this 1 is been encountered, I'll move to its right. Okay, I'll see that if there exists a right of it. Okay, if there exists a right of it, then just push it, push it. So I'll push 3 here first of all, and after that I'll push what, I'll push its left. So you have to push the right first and then the left first, because left will be popped out first, and in the stack we can pop out the element which is at the top. So what I'll do is I'll then push 2 into it, and after that, after traveling we are having a stack, the element inside that stack will pop out the element from the top. So 2 is being popped out. Okay, so as soon as we are popping out, okay, what I have to do is I have to push it to this stack. Okay, so Rishabh, push it to this this, not the stack, this vector. So okay, I'm doing it. So here we have 2. Now after traveling or after going to that 2, what you have to do is to see that there should be the right of it and push it to that stack. Okay, so what I'll do, I'll push 6 to this stack. Okay, and after pushing up 6 to this stack, what I'll do, I'll push 5 to this stack. You can see that 5. I'll push 5 to the stack. Okay, pretty simple. I'll push 5 to the stack. Now after pushing 5 to the stack, what I'll do, I'll pop out the element from the top. I'll pop this 5 out, and what I have to do is I have to just go to my vector and add it. So I'll push 5 to this. Okay, adding up 5 to it. Now as soon as I have added the 5 of it, I'll see now what I have to do, I have to travel to its right, and I have found that there is nothing inside the right and nothing inside the left. What I'll do, I'll come back here and pop out 6 again. Okay, so after popping out 6 again, what I have to do, simply just put it inside this vector. After putting this inside the vector, what I have to do, I have to travel to its left and right. Just travel to its left and right. Okay, no problem. Null. Okay, no problem. Go to the stack, take out the element from the stack. Okay, we have 3. What we have to do, just go and push it to the vector. Now after moving to this, we'll see that there is no left and right, and also the stack is empty. As soon as we find that the stack is empty and nothing is there, we have traveled the whole tree, binary tree, and you can see that the answer is same, 12563 and 12563. And this is very simple in code. Like, the coding of this is really simple. You have to just make a stack and just travel to the root. First of all, first line should be pushing it to a vector, and then pushing the right. If there is right, then push it to the stack, and then push the left of it. And else, if you don't find it, okay, just what you have to do is pop out the element from the top and just make it like again do it. So you have to basically try with the while loop and if. Okay, so I hope this is clear to you. I have told you the recursive code, and if you want, you can go and check out the what you can say, the iterative rule also. So let's just go and check out the iterative code also. For first of all, so this is the iterative way. First of all, declaring a vector, and then a stack will having a while loop. The root should be there and the stack should not be empty. Again entering into it, if we found the root, then what you have to do, push back the root. If we have the right of it, push it into the stack, and after that push the root, like make the root is equals to roots left. Okay, so make the root roots left. And if this is not satisfied, like this is not satisfied, what you have to do, you have to make the root as stack of the top and pop out that. Okay, so I think it is clear to you the code. And this after coming from this whole while loop, you have to return the answer. Okay, so this is the code. I hope you get the approach of it, the approach that I have told you, and I hope you like the video. If you do like the video, make sure to subscribe to the channel. Thank you. I'll meet you again tomorrow. Bye.